Introduction to Algebra. In this lesson, we will look at variables, constants, and coefficients, an algebraic expression, like and unlike terms, the arithmetic laws, and how to simplify algebraic expressions. In algebra, we used symbols to represent numbers such as x, 2y, ab square, theta, and pi. Theta usually represents the angle. Pi represents the constant 3.142, which is used in a circle. We usually use x to represent an unknown value. Since x can take any value, we call it a variable. To vary means to change. An unknown with a fixed value is called a constant, such as pi. All numbers are constants, such as 5 has a value of 5 and nothing else. Let us now take a look at an algebraic expression. The terms of an expression are separated by operation symbols, and they are written in descending powers of x. Here we have 4 terms, 1, 2, 3, 4. And the powers of x are x cubed, x squared, x, and followed by a number. The coefficients are numbers beside the variables, such as 3 is the coefficient of x cubed, -2 is the coefficient of x squared, and 4 is the coefficient of x. Constants such as -5 are written at the end of the expression. We do not use the multiplication sign as this will be mixed up with the variable x. We write multiplication as 3 times x times y squared without any symbol in between. And this means 3 times x times y times y. Notice that the power only belongs to y. The square belongs to y, and it means y times y. 3xy squared can also be written as 3 bracket x bracket y squared. Brackets are used to represent multiplication. 3/4 x is often written as 3x over 4. We next take a look at like terms. You can only add or subtract like terms. Like terms have the same variables put to the same power, but they can have different coefficients and order, such as 3x and -7x have both variable x but different coefficients. They are like terms. Here we have y squared belonging to all the terms here. Although they have different coefficients, they have the same variable y squared and the same power of square. Similarly, x4y cubed. Once again, we have the same variables but different coefficient. And finally, x cubed y squared and y squared x cubed is also the same variable, although the order is different. But as long as they are the same variables and having the same powers of y and same powers of x, they are considered as like terms. On the right hand side, we have the unlike terms, where you can see that 3y and 7w have different variables y and w. 5x and 5x cubed. X and x cubed are different variables. Xy squared and x squared y are different variables. Therefore, all these are unlike terms. We next take a look at some important laws in arithmetic. Here we look at the commutative law of addition and multiplication. 3 plus 5 equals 8, so is 5 plus 3. Therefore, 3 plus 5 equals 5 plus 3. In addition, the order of adding is not important. Similarly, in multiplication, 2 times 5 equals 10. 5 times 2 also equals 10. Therefore, 2 times 5 equals 5 times 2. The commutative law, therefore, states that the order is not important when we add or multiply. Next, we look at the associative law of addition and multiplication. In this law, we see that we can add any pair of numbers first, such as we can add these two numbers first, 2 plus 3 to give us 5, so we have 5 plus 5 equals 10, or we can add the last two numbers, 3 plus 5, to give us 2 plus 8, which also equals 10. Therefore, 2 plus 3 in brackets plus 5 equals 2 plus 3 plus 5 in brackets. The same can be seen for multiplication. 2 times 3 times 5. Multiplying 2 and 3 first, we have 6 times 5 equals 30. And if we multiply the last two numbers, we have 2 times 15 also equals 30. Therefore, once again in multiplication, we can add any pair, or rather we can multiply any pair of numbers first. Next, we take a look at how we simplify an algebraic expressions. We only add or subtract the coefficients, leaving the variables unchanged. Such as, first we identify those with the same variable, that is 3x and 5x, and we add their coefficients, 3 plus 5, to give us 8x. The variable does not change. Similarly, negative 2xy plus 7xy. 7 minus 2 is 5. And the variable remains unchanged, xy. In example 2, we look at subtraction of two fractions. Once again, the variables remains unchanged, and we simply subtract the fractions. Making the same denominator, we have our answer 5 over 12 xy squared. Next, we look at multiplication, division, and square root. In multiplication, we multiply numbers first to give us 15. Next, we multiply the same basis. We add the powers. 8 power of 3 plus 2 equals 5. Again, the same basis, b times b squared, adding the powers give us b cubed. b is to the power of 1, which is usually not shown. The square of 5a squared b cubed simply means 5a squared b cubed times 5a squared b cubed. 5 times 5 is 25. A squared times a squared is a to the power of 4. And b cubed times b cubed is b to the power of 6. We simply add their powers. When we multiply two fractions, it's just like multiplying numerical fractions where we cancel out their common factors. A is also a common factor, and b squared is a common factor. Hence, our answer is 1 over 2b squared. For division, normally we write it as a fraction. Then we can simplify by reducing it to the lowest term. Reducing the numbers first, we have half. And the common factor of b is cancelled, giving us b in the denominator. Finally, we look at square root. To take the square root, we first take the square root of the number. Square root of 9 is 3. Next, square root of a squared is a. And b to the power of 4, the square root is b squared. We simply halve the powers. Finally, we look at an important law called the distributive law. We can understand the distributive law by thinking of it as an area of length a and b plus 3. This length here is a, and this length is b, and this length is 3, giving us the whole length here, b plus 3. Now we know that area of the whole thing is the same as the sum of the individual areas, AB plus 3A. Therefore, in the distributive law, the number outside the brackets is distributed to every term within the brackets. We look at another example. Here we have a rectangle of side negative a, 3a. And the other side consists of 2b and the side negative a and 5. Working out the individual area, we have negative 6ab. Negative times negative is positive, 3a squared, and negative 3 times 5 is negative 15a. Therefore, we have negative 6ab plus 3a squared minus 15a. This concludes the lesson. Thank you.